Right, good day and welcome. In this lesson, we'll be sketching cubic function, or give you a basic introduction to how cubic function looks and how to sketch it if we have a equation. So, cubic function basically looks as follows. There's two stationary points. There's generally three x-intercepts, can have two, can have one. There's a point of inflection, a point where graph changes from concave down to what we call concave up. The highest turning point is referred to as a maximum turning point. The lowest turning point referred to as a minimum point, minimum turning point. Right, for stationary point, we're going to use first derivative to solve that. For point of inflection, we're going to use second derivative, and to get x-intercepts as well as my y-intercept there. For my x-intercepts, I'm going to use factor theorem. Alright. So knowing the shape, you can see it turns twice. Find y-intercept, we're going to, as usual, let x equal to 0. To find the x-intercept, y is 0. We're going to have to know how to use the factor theorem to find one factor the equation before we can factorize further. For stationary points, we'll find the first derivative, solve for x. First derivative we make equal to 0. That values we get for x will always go back in the original equation. Find the point of inflection, we're going to have to find the second derivative, make it equal to 0, solve for x, substitute back in the original equation. A maximum turning point, greatest y values you could see, right, point from where the graph is concave down. Minimum turning point at the bottom is point where the graph is concave up. Right, so without further ado, look at the problem. Alright, so given f of x equal x cubed minus 4x squared minus 3x plus 18, sketch the graph. So to sketch the graph, we first have to find the y-intercept. Generally 1 mark, so y-intercept x equals 0. So f of 0, 0 cubed, 0 squared, 0. So my final answer, that all becomes 0 there, is 18. So my y-intercept is at 0 and 18. Alright, then we must be able to get the x-intercepts. Right, so look at the equation, linear factors of 18 there. They're all listed. Negative 2 there gives me a value equal to 0. If I put negative 2 cubed minus 4, negative 2 squared, negative 3, negative 2 plus 18. So x plus 2 is referred to as a factor. So if I factorize, I have x plus 2. X times x squared gives me x cubed. Positive 2 times positive 9 gives me 18. 2 times x squared gives me 2x squared. I need to get to minus 4x squared, so minus 6 times x gives me minus 6x squared, plus 2x squared gives me minus 4x squared. So 1 mark for x plus 2. Another mark for the factors there, x squared minus 6x plus 9. If I factorize that, it becomes x minus 3 times x minus 3. X times x squared, negative 3 times negative 3, positive 9. But minus 3x gives me minus 6x. So my x values, or my roots, x equal negative 2 or x equal 3. So coordinates minus 2 and 0 and 3 and 0. I have 2 roots only. Alright. Alright, now we also need the stationary points. So calculate the coordinates of stationary points. Normally 5 to 6 marks. So first we find the first derivative. So 3 times 1 gives me 3. 3 minus 1 gives me 2. 2 times negative 4 gives me negative 8. 2 minus 1 gives me 1. 1 times negative 3, negative 3. 1 minus 1, 0. So x falls away. 18 is 0. Right? So first derivative must be equal to 0 for stationary points. So 0 equal, and if I factorize that, 3 is a prime number, so it can only become 3x times x. Minus 3 also a prime number, minus 3 times 1. For the middle term, 3x times negative 3 gives me negative 9, plus 1x gives me negative 8x. Right? So each bracket there, if I equate equal to 0 using zero factor law, x equal to negative 1 over 3 or x equal to 3. These two values we get will always go back into the original equation of f of x. Not into the first derivative, but the original equation. So if I use f negative 1 over 3 cubed, negative 4, negative 1 over 3 squared, minus 3, negative 1 over 3 plus 18. Get the answer of 500 over 27, or if you want to as a decimal, 18,52. Put in f3, 3 cubed minus 4, 3 squared minus 3 times 3 plus 18 gives me 0. So my turning points, or my stationary points, coordinates at minus 1 over 3 and 500 over 27, or 3 and 0. Alright. We also still have our point of inflection. So determine point of inflection. So first, find first derivative. 3 times 1, 3, 3 minus 1, 2. 2 times negative 4, negative 8, 2 minus 1, 1. 1 times negative 3, negative 3, 1 minus 1, x to the power 0 falls away. Then I have to find the second derivative, so 2 times 3 gives me 6. 2 minus 1 gives me 1. 1 times negative 8 gives me negative 8. x1 minus 1, x to the power 0, that falls away. So again, for the point of inflection, my second derivative must equal 0, so 0 equals 6x minus 8. Take 8 over, 8 equals 6x. So x equals 8 divided by 6, which simplifies to 4 over 3. Again, that x value must go back in the original equation. So I substitute back in the original equation, 4 over 3 cubed, minus 4, 4 over 3 squared, minus 3, 4 over 3 plus 18. Give me an answer of 250 over 27. So my coordinates are 4 over 3 and 250 over 27. There's your mark allocation. Right, so now we can put the function. So to plot all these points, first I have x-intercept at minus 2 and 0, and 1 at 3 and 0. Take note, my stationary point was at minus 1 over 3 and 18,52, or 500 over 27. Another one at 3 and 0. Point of inflection, where the graph changes from concave down to concave up, was at 4 over 3 and 250 over 27. And there, if I plot, turn through my y-intercept 18 there, all the way, and then I turn on that back, and there's my graph plot. Take note, A is positive, therefore the graph goes from concave down to concave up. So positive, concave down to concave up. Right, one last question. If you enjoyed the lesson so far, please like, share and subscribe. Right, but let's look at one question that always gets tested with stationary points. Determine the average gradient between the stationary points. So minus 1 over 3, 500 over 27, and 3 and 0. So for average gradient, f negative 1 over 3 minus f3. So that is for my y values, divided by minus 1 over 3 minus 3. So 500 over 27 minus 0. That becomes minus 3 and a third, which gives me then minus 50 over 29. Alright, so this is just a basic introduction. Next lesson we'll plot at least another 2 functions. But I hope you understand and we're still together. Wish you nothing but the best. Bye.